So, Chapter 6, Foundations of Math and Pre-Calculus 10, is a continuation and is a further exploration of linear functions. So, in Chapter 5, we talked about relations, we talked about special relations that were functions, and we talked a lot about linear functions. Now we're going to explore deeper linear functions because this shows up in every math that you do from now on, ever and ever. Functions are important, function notation, working with linear graph in math and in science. You will have to draw graphs, you'll have to get information from the graphs. Okay, so it's basically, this first section here for sure is a continuation of Chapter 5. It's really not that difficult. So 6.1, we are exploring deeper rates of change, which are slopes. So let's take a look at the first example that you would see in your textbook, page 333 right here. When we're talking about slopes, we're talking about steepness, and you guys mentioned that word last chapter. Okay, how steep is something? How steep is a roof? How steep is a ski hill? How steep is, the hill you're climbing up? Whatever. In this example, they talk about roofs of houses. All right. Now you can see that we have some different steepness of roofs here, or different pitch. Okay, pitch is a word that's used in science for sound, for a certain frequency, okay? But it's also used in construction for the steepness of a roof, okay? It's a little bit more specific than that, but maybe we'll cover that. If you take workplace, I think talk a little bit more about pitch for roof. It might show up in this chapter. But anyways, if you look at these diagrams here, the steepness of a roof can be calculated using rise over run, or rise divided by run. The height from one point, any point on the roof, and we'll take the kind of the lowest part of the roof here, to the highest part of the roof. If we take a look at that and we count those squares, okay, it doesn't matter what the squares are right now, but the rise would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? So a rise of 13 units, whatever those are, and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So a run of 13, a rise of 13. If I was asking you to calculate the slope, you would do this. 13 units divided by 13 units equals a slope of 1. Okay? Which means that for every horizontal unit you would move over to the right, you would move up 1 horizontal unit. Okay? So 1, 1. 1, 1. Just like this. So I'll maybe try and put a different color. But every 1 unit horizontally, you go 1 unit up. Horizontally, up, and so on. All the way that pattern follows throughout. Let's talk about the second one. What's the rise here? You guys count it in your book. Okay, it looks like how many units? 7. 7 units here. So a rise of 7 and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get 12? You got that right? So 7 over 12. Now, if you can't simplify that, you can just leave that as 7 over 12, or you can write it as a decimal, of course. Right? So it's good to express it both ways, a fraction and a decimal. But 7 divided by 12 is 0.583. So 0.583. And that would be your slope. Now, as far as units goes, we're not really too concerned about units just right now. I think you guys understand slope, right? And the same would be for this one. Which of these roofs would have the greatest slope just by looking at them? Yes, the third one, okay? Roof C. Because you can kind of see here, pardon the pun, you can kind of see, I know, not great. Here is, oh, big, that thick black line. Okay, look at, there is the slope. That's weird. There's the slope of that roof. Now look at, if we just translate that over, yeah, technology. Look at that, way steeper. But over here, all right, not as steep. Okay, so this one here, this roof right here, whoa, jelly. This roof, come on, work with me. That roof right there, look at that. Steeper. Steeper. Got it? Got it? All right, that's easy. Okay, So if I asked you to determine the slope of these lines, could you do that? A, go ahead, take 20 seconds and do A. Find the slope of A. All right, so when we're determining the slopes of lines on a graph, I want you to notice two things, the rise and the run. In order to keep the positive or negative signs of the slope appropriate, what you're going to want to do is you're going to want to count from the point on the left, okay, to the point on the right. If you count from the point the right to the left, that's okay too. But I'm suggesting that you always start with the left point. But I am going to show you how it will work both ways. It doesn't matter which point is the first point. I always start with the point on the left as being point 1. But you don't have to. But watch. So for this one, it's a rise of 1, 2, 3, 4, 5, 6. Do you have to count that even? Well, that's negative 3 to positive 3. So that's plus 6. Now, when you're going up, that's a positive rise. Make sense? When you're moving to the right, that is a positive run. So that's positive 10. Okay? So that gives us 0.6 as a slope. Over here, though, when you're going from left to right, notice how you have to go down to get to the other point. So that's a negative rise, which means this number is negative. So that's why this is a negative there. Everybody see that? Now, which way do we go here? Well, we go right, so that's positive. Okay? Does everyone understand that right now? Yeah. Yes, yes, you can have a negative run. I'm going to show you that right now. If you understand this, okay, I just want everyone to understand this right now. I'm going to do it a different way, and I'm going to show you where, yes, a negative run could come in. Yeah, question? Yes, exactly. That is an inference, an observation, a pattern that we're going to. You should be able to notice that yes, if the line from left to right now goes in the up direction, okay, it's like uphill from left to right. Yes, that's a good observation. That is always going to be a positive slope, and we're going to summarize that a little bit later in the lesson. And going down, that is a negative slope. But let me just address this question, okay? So let's say we started with B. That's totally fine. Then we're going to do rise over run. So watch what I do. A rise. To get to the next point, the other point that I'm going to use, I have to go down. So 1, 2, 3, 4, 5, 6. No problem. That is negative 6. Now the run, you keep going from where you ended off here. You went down. Now you have to go left. And that would represent a negative run. 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a negative 10. So when you have to move left, it's a negative run. Yep. So that will be the slope then here. If you calculated using these 2 points in that order, it would be negative 6 divided by negative 10, which would still give you the exact same slope. Because a negative divided by negative is positive. Does that make sense? Does that help? So it's important to know a couple things we've already uncovered, so this is great. The first thing is that someone mentioned here, and yes, we can say it's always true, this is always a positive slope if it goes up from left to right. This is always a negative slope if it goes down from left to right. Okay? The other thing is, it doesn't matter which point you use as point number 1, because the slope will always work itself out. Okay? So I used B as the first point in the second time, and you notice it came out to the exact same. All right, questions about that? All right, then let's make these observations official. Here's the explanation, and this is directly from your textbook. You do not have to copy this word for word, all right? But this is just an explanation here that, again, this sort of line going up from left to right is always going to yield you a positive slope. The line going down left to right is going to be a negative slope. So I don't know if it makes sense to you now, but somewhere between a positive number and a negative number has to be what? Has to be 0. So somewhere between a positive and a negative, there has to be a slope that represents a 0 slope. And in this case, we know that a horizontal line segment, so a horizontal line or line segment, is a 0 slope. It's neither positive nor negative. Okay? You need to understand that. All right, a horizontal line has a slope of 0. The explanation would be this, and here it is right here. The rise between this point right here and this point right here is 0. Because they're on the same horizontal level, how far do you have to go up or down to get to the next point? You have to go 0 units. So that's a 0 on top, and it doesn't matter what the run is because this is any number other than 0, right, which is going to be 1, 2, 3, 4, 5, 6. 0 divided by 6 in this case would equal 0. Okay? So horizontal line, 0. The other part of this is a vertical line. Okay, now we talked about vertical lines before in chapter 5. Vertical lines they're straight lines, but they're not functions, right? And why are they not functions? Well, because there's a lot of points that are in a vertical line here, obviously. And a funny thing happens about its slope. Because the rise is a number, but the run is 0, I don't know if you remember this or know this, but you cannot divide by 0. Mathematically, that does not make sense. You can't have a certain number of things and divide it into 0 groups. You would be like making it disappear, Rachel. That's not allowed, right? Making things just disappear into thin air. No. Actually, dividing by 0 and 0 dividing by something is not 0. It's not. If you have 0 things to start off with, okay, technically, if you have 0 things to start off with, you could split that into as many groups as you want. And how many would you have in each group? You would have 0 in each group. That's your answer. If you have 5 things, and you split those into 0 groups, it's impossible. So if you want to check on your calculator, you go ahead and check on your calculator. 2 divided by 0, you'll get error. Okay? You cannot divide by 0. A number divided by 0, or even 0 divided by itself, is undefined. It's called undefined. So whenever you have 0 in the denominator, you don't get a real answer. There is no answer. It's undefined. Okay? So a fraction with a denominator 0 is not defined. So we call that undefined. And that's important. It's an important distinction to make. A lot of kids, in grade 9 and 10, get that mixed up. When 0 is on the top, the answer is 0. When 0 is on the bottom, it's undefined. Okay? It's not possible. There are some things that you just can't do in math. You can't take the square root of a negative number and get a real answer anyways. You actually can get a complex answer that is an unreal answer. But I won't get into that yet. That's coming later. Yes. All right. So any other questions about slopes there? No? Yes? Girls, do I have a discussion back there? Question? Want to let us in on it or no? Yes? No? Not today? Okay. Make sure it's a math discussion if there's any discussion going on. Thank you. All right. Now, the slope of a line. We've talked a little bit about this as well. Let's remember here that when we're doing this kind of question, that we remember how we do that. So, here's an example here that I want you to look at. So you don't need to graph them, although you could sketch them roughly if you wanted to have some kind of idea of what slope you would be expecting. So if you want to determine the slope, where's the first point? Well, that's a negative from 0, 0. It goes negative 5 and negative 3. So it's going to be right around here. This second point is going to be 2 and 1. So first of all, what sign should this slope end up to be? Yeah. Yes, positive. It's going up from left to right. So it should be a positive slope. Now, how do we find out the exact measure of the slope? Well, we got to do rise over run. But it's a little bit difficult to calculate to look at a graph. Or if you're just given points and you don't graph them, then you can't just count squares and stuff, right? So how do we do that? Do you remember this from last semester? Remember last semester? Last chapter? Okay? So let's do this. M is the symbol for slope, right? Which we know is the rise over the run. And the rise can be calculated, if you remember from last chapter, it's the change in y divided by the change in x. And how is the change in y actually defined? y2 minus y1 divided by x2 minus x1. Now, it doesn't matter which point is x1, y1, and which point is x2, y2. It actually doesn't matter. Because as I demonstrated before, you're going to get the same slope whichever way you calculate it. Remember this one? Doesn't matter. But what does matter is throughout the question you keep it consistent. So, let's say this is point 1, right here, C, and let's say this is point 2, D. Alright, so M equals, what's the change in y? Well, if this is point 2, let's start off with the y value in point 2. 1, and we subtract the y value in point 1. So 1 minus negative 3. Does everyone see that? 1 minus negative 3. It's very important to keep your signs, make sure you pay very close attention to your signs. Okay, it's 1 minus negative. Now we go to the denominator here where we have x2, which is going to be this value. That's 2. We always subtract negative 5. Okay? So, when you have this, you simplify. 1 minus negative 3 is the same as 1 plus 3. And I'll just show this step so you can see this when you look back to your notes if you need to. 2 minus a negative 5 is the same as 2 plus 5. So that's going to be 4 over 7. There is your slope. It's a positive value. That's good. We would be going up 4 units and over 7 units. Okay? Questions? Okay, so make sure you have this written down right here. The slope of a line is y2 minus y1, x2 minus x1. And here's the little diagram from your textbook if you need to see that. So just real quickly, I'll do this real quickly down here. You don't need to copy this down if you don't want to. But just to confirm with you that if we changed around the points, like point 1 and point 2, we would get the same slope. So watch this. That's what I'm going to do right now. I'm going to say this is point 1 and this is point 2. And so I'm going to do this. Negative 3 minus 1 divided by negative 5 minus 2. That's going to be negative 4 over negative 7, which simplifies to 4 over 7. You get the exact same answer. See that? It doesn't matter which 2 points or which order. Okay? Questions? Easy? Okay, let's talk about just a few discussion questions, and then I'll let you go on your assignment. When you look at a line on a grid, or on a Cartesian plane is another word for this, Cartesian plane, or the coordinate plane, how can you tell whether it's positive, negative, 0, or undefined, the slope of a line? How can you tell? How can we tell it's positive again? Just to review. It's going up, left to right. Good. Negative, down, left to right. 0 is a horizontal line. Very good. And an undefined slope is a completely, perfectly vertical. Good. Why can you choose any 2 points on the line to determine the slope? Why would you get the same slope if I chose any 2 points on the line? Let's say those ones in green, or these ones right here in red. Why would it be the exact same slope? Any volunteer answers there? Yeah? No? Okay. Okay, because it's linear. We're going to say something different? Okay, anything else? Yep. Okay, because we're dealing with a straight line, Okay, and all those answers, I'm just going to summarize that. That was really good. Because it's a straight line, we are dealing with, really we're dealing with similar triangles, right? So from this point, if I go up 2 and over 4, I don't exactly here, but that was the example. And I'm going to go up 4, and I would be going over 8, right? So 2 over 4 is the same as 4 over 8, which would be the same as 6 over 12, let's say. So because it's a straight line, any 2 points will yield the same simplified slope. It doesn't matter which 2 points you would use, okay? Because it's straight. Good, good. And finally, when you know the coordinates of 2 points E and F, you use the formula to determine the slope of E and F. Does it matter which point has the coordinates x1, y1? We just did an example like that. Does it matter? Does it matter which is the first point and the second point? No. Right? And because of this example right here. Okay? You're going to get positive over a positive, or you're going to get a negative over a negative. Or you might get a negative over a positive, and the other way you would get a positive over a negative. Both would yield you the same answer. All right, there's your lesson on slope today, continuation. This is the 6.1 lesson, and I'm going to give you your assignment here now. Okay, your assignment from 6.1, guys, get started on that.